Hello, and today we're going to be talking about trigonometric ratios. Now, this name comes from trigonometry, where trigonometry is the study of triangles. And so that's what you've been doing until you got to this video, I'm assuming. You've been looking at lots of different things involving triangles. So you've been studying triangles, you've been doing trigonometry. So we're moving more specifically to looking at right trigonometry or right triangle trigonometry. So the study of right triangles specifically. And so there's some cool things that we see with right triangles. We see the Pythagorean theorem being able to be used. We also see that there's this distinct relationship between angles and sides in right triangles, and then there's similar versions of them, and it continues to stay the same all throughout. And so this relationship between them is called trigonometric ratios. So if we know the angle, we automatically know this relationship between two of the sides. We automatically know the relationship between, say, the side opposite of it and the side adjacent to it, or the side opposite of it in the hypotenuse, or the side adjacent to it in the hypotenuse. We know the relationships between any two sides based off of the angle alone. Well, how do we do this? Well, first, there are three things that are really important for you to be able to know. Actually, four. The first is that, hey, pick an angle. In this case, we have an angle here, labeled theta. Some people label it A, some alpha, whatever, some kind of symbol. You know this is an angle because it's formed by two sides intersecting. So we select this angle, and from the point of view of this angle, we will now label the sides. The first thing we're going to label is the hypotenuse. Why? Because we know where the hypotenuse is on a right triangle. It is always opposite of the 90 degrees, or it's always the side that is not touching the 90-degree angle. So obviously my hypotenuse will be here. And I'm going to abbreviate hypotenuse with HYP. Okay? So the second thing we want to do is find our opposite side. The opposite side will be the side that's opposite of the angle. In other words, for this angle, it is the side that is not touching it, or the one that's directly opposite of it. So that would be here. Okay? So thirdly, the one that would be left over would be the adjacent side. So that would be here. And I abbreviated opposite OPP, and I abbreviated adjacent ADJ. This is generally what most people do. Sometimes people just go HOA, which is fine as well. So what does this mean? Well, if I have a right triangle and I know the angle, and from the angle I designate the sides, the hypotenuse, the opposite, and the adjacent, I then have these ratios that I can form. There are 6 in total. I'm going to show you all 6, but we're only going to use 3 mainly. That's because the other 6 are just the inverses of them, meaning that they're just reciprocals or flipped. And I'll show you that. The first one, though, is sine. It's spelled S-I-N-E. It's abbreviated S-I-N. Okay? And in fact, you know what? I'm going to actually spell that out. I wasn't going to, but I'm going to spell it out. This is sine. So not sin, but sine. And it is sine of the angle is equal to the opposite side divided by the hypotenuse. Every single time, sine of that angle is going to be equal to the opposite side divided by the hypotenuse. Okay? That's kind of cool to know. If I know the opposite side and I know the hypotenuse, I then know that sine of that angle will always be whatever I get when I divide those two. It's very useful, actually. Okay? The next thing here is cosine. So cosine, C-O-S-I-N-E, cosine, abbreviated C-O-S, of the angle will be the adjacent side divided by the hypotenuse. The adjacent side divided by the hypotenuse. So I know the side that's adjacent to it. Adjacent means next to it. So it's the leg that's next to it. That's not the hypotenuse. And then we have the hypotenuse. Adjacent divided by hypotenuse will give us the cosine. The last one that's popularly known and used is called tangent. So some people call it tan, T-A-N, because they see that. So that's the abbreviation, T-A-N, but it's tangent. T-A-N-G-E-T-E-T. So those of you that actually know what the word tangent means, it means that it's going at a 90-degree angle away from something. So it's tangent to it. So like, for example, for a curve, tangent would just touch it just at that one point of intersection, but at that point it would be 90 degrees exactly. So that actually has something to do with the fact that we have this right triangle here. But anyway, so tangent, abbreviated TAN, would be equal to the opposite side divided by the adjacent, the two sides that form the right angle. Again, tangent having to do with right angles. So tangent of an angle is opposite divided by adjacent. Okay, so these three trig ratios are very important to know and to recognize and when to use it. So a lot of times people have come up or use a mnemonic device in order to remember it. They call it Sohcahtoa. So Sohcahtoa. And so they use this to remember how the trig ratios are in relation to one another. So sine is equal to opposite divided by hypotenuse. Cosine is equal to adjacent divided by hypotenuse. Tangent is equal to opposite divided by adjacent. So Sohcahtoa. Sohcahtoa. So that's a way that people use to remember that. Now, we're going to look at different ways to use this soon enough. But as I said, there are three others that I want to show you. That way that you know their existence. You don't have to ever use them because they're just going to be the reciprocals of these. Now remember, a reciprocal means you flip the fraction. So I'm going to now erase this and show you the other ones that we use. So if you want to pause and copy it down, go ahead. Okay. So the three others that we use still have to do with the adjacent and opposite and the hypotenuse. The first one is called cosecant, abbreviated CSC, and I'll actually write it out, cosecant. And it is directly related to sine. It is the inverse or reciprocal of sine. So CSC of theta would then be, if sine was opposite over hypotenuse, if we flip that, this would be hypotenuse over opposite. Okay? All right, so the second one is secant, which is a special type of line in regards to a circle. It's a line that goes through a circle. So anyway, secant is abbreviated SEC, and is going to be your hypotenuse divided by your adjacent side. Okay, so your secant of the angle is going to be the hypotenuse divided by the adjacent side. And the last one is cotangent. And so cotangent is COT, and that is going to be the adjacent divided by opposite. Okay, and so we see then that cosecant, secant, and cotangent are just reciprocals of the others that we saw. So again, that's why I say I'm supposed to show this to you so that you know what they are. So here, you know what they are. There are lots of other trigonometric properties and principles that will use knowing what these are and understanding how to use them, but we will not be looking at that in the practical sense of what we're going to be doing. So if you'd like to learn more about it, feel free to leave a message and I can do some things on them. But for now, we're going to stick with the sine, cosine, and tangent because those are the ones that are going to be most used in the practical applications in which we're going to be doing and looking at. Okay, so that's trig ratios, and I'll show you a couple examples of setting them up to use them and a few. I'll see you soon.